Imagine standing in a quiet Italian square early in the morning before the crowds arrive. The air feels calm, almost frozen in time, and in front of you stands one of the most famous structures ever built by humanity, a tower that was never supposed to lean. Yet for more than 8 centuries, it has refused to fall. The Leaning Tower of Pisa is not just an architectural landmark. It is one of history's greatest engineering accidents, turned into a global mystery. Because from the very moment construction began in the year 1173, something went terribly wrong. The ground beneath the tower started sinking. Slowly, silently, almost invisibly. At first, the builders believed the problem was temporary. They continued stacking heavy marble stones higher into the sky, unaware that every new level made the imbalance worse. And then, the tower began to tilt. Imagine the fear of medieval engineers watching their masterpiece slowly leaning to one side, with no modern science to explain why. No computers, no soil analysis, no structural simulations, only intuition and hope. The land in Pisa looked stable on the surface, but hidden underground was a dangerous combination of clay, sand, and water-saturated soil, too soft to support the enormous weight pressing down from above. Instead of standing firm, the foundation behaved almost like a sponge. And gravity never forgives mistakes. Within just a few years, the tilt became impossible to ignore. Construction suddenly stopped, not because the builders wanted to redesign the tower, but because Europe itself was entering a period of wars and political conflict. For nearly a century, the unfinished tower stood abandoned. And strangely, that pause may have saved it. During those decades, the soil beneath the structure slowly compressed and stabilized. When construction finally resumed, new architects faced an impossible challenge. How do you complete a tower that is already leaning? Their solution was unusual. Instead of correcting the tilt, they tried to compensate for it. Upper floors were built slightly taller on one side than the other, creating a subtle curve. If you look carefully today, the tower is not perfectly straight. It gently bends like a banana, an improvised correction frozen forever in stone. But even this clever adjustment could not stop gravity entirely. Year after year, century after century, the lean continued growing. And people began asking a terrifying question. Would the tower eventually collapse? Or had humanity accidentally created a structure capable of surviving against all odds? To understand why the tower still stands today, we must look deeper, not at the marble walls, but beneath them, into the hidden science underground. For centuries, people believed the Leaning Tower of Pisa survived purely by luck. But modern science tells a very different story. The real secret lies beneath the surface, hidden deep underground where no tourist ever looks. Engineers eventually discovered that the soil below the tower is made of alternating layers of clay, fine sand, and marine deposits left behind by an ancient coastline. Hundreds of years ago, this entire region was much closer to the sea. That meant the ground contained trapped water, making it soft and unstable under heavy pressure. When the massive marble tower was built, its enormous weight pushed unevenly into this fragile soil. One side compressed more than the other, and slowly, gravity began pulling the structure downward. But here is the surprising part. The same weak soil that caused the tower to lean also helped prevent it from collapsing. Because instead of cracking violently, the ground absorbed movement gradually, acting like a natural shock absorber. In modern engineering, this effect is known as soil structure interaction. The tower and the ground were not fighting each other. They were adapting together. Over time, the tilt increased so much that by the 20th century, scientists feared disaster was inevitable. Measurements showed the tower leaning more than 5 degrees from vertical. That may not sound extreme, but for a structure weighing over 14,000 tons, it was dangerously close to structural failure. Experts predicted that without intervention, the tower could fall within decades. Visitors still climbed its spiral staircase, unaware they were walking inside what many believed was a future collapse site. Governments faced a difficult decision. Should they attempt to fix the tower and risk destroying it? Or leave history untouched and hope it survived? In 1990, authorities made a dramatic choice. The tower was closed to the public for the first time in modern history. An international team of engineers, historians, and scientists gathered to solve a problem that had existed for over 800 years. Their challenge was unprecedented. They could not simply straighten the tower completely. If they forced it upright too quickly, the sudden shift could cause catastrophic cracking. Instead, they needed a solution slow enough to respect the structure's delicate balance. Engineers began experimenting with counterweights, massive blocks of lead placed on one side of the base to reduce pressure. Steel cables were anchored deep into the ground to stabilize movement. And then came the most daring idea of all. Instead of pushing the tower back, they decided to remove soil from underneath it. Carefully, gradually, millimeter by millimeter. A technique so precise that the tower itself slowly began correcting its own lean. For the first time in centuries, the tilt started decreasing. Humanity was not forcing the tower to change. It was guiding gravity itself. As engineers carefully removed soil beneath the Leaning Tower of Pisa, something unexpected began to happen. The tower slowly responded, almost as if it were alive. Sensors placed throughout the structure detected movements so small they could only be measured in millimeters. Every shift was monitored day and night. One wrong calculation could trigger irreversible collapse. For centuries, people believed the tower leaned because of poor construction alone. But new research revealed that medieval builders unintentionally created a structure far more flexible than most stone towers of its time. Unlike rigid buildings, the tower's circular design distributed stress evenly around its walls. Its hollow interior and spiral staircase reduced internal weight, allowing the structure to adjust instead of fracture. In other words, what looked like a mistake became an accidental engineering advantage. This flexibility may also explain one of the tower's most famous legends. According to historical stories, the scientist Galileo Galilei once used the Leaning Tower to perform experiments on gravity. He reportedly dropped two spheres of different masses from the top to demonstrate that objects fall at the same speed regardless of weight. Whether the experiment truly happened remains debated among historians. But the symbolism remains powerful. A flawed tower helping humanity understand the laws of physics. Meanwhile, the real modern experiment continued below ground. Engineers removed small amounts of soil over several years, allowing gravity to gently guide the tower back toward stability. The process required extraordinary patience. Too fast, and the tower could crack. Too slow, and the structure might continue sinking. By the late 1990s, results became visible. The lean began decreasing for the first time in centuries. The tower had moved several centimeters back toward safety. It was a historic moment, not by rebuilding the monument, but by understanding it. In 2001, after more than a decade of careful stabilization, officials finally reopened the tower to visitors. Millions returned, climbing the tilted staircase once again. But this time, hidden technology constantly watched over every movement. Laser monitoring systems tracked microscopic shifts. Satellites measured its exact position from space. The Leaning Tower was no longer just a historical monument. It had become one of the most closely monitored buildings on Earth. Experts announced remarkable news. The stabilization efforts had reduced the tilt enough to ensure safety for at least 200 years, assuming no major environmental changes. For the first time in over 800 years, the tower was no longer actively falling. But the story was far from over. Because the forces that nearly destroyed Pisa's most famous landmark are still shaping cities across the modern world today. For centuries, one question puzzled historians and engineers alike. How did the Leaning Tower of Pisa survive powerful earthquakes that destroyed surrounding buildings? The region of Tuscany has experienced multiple strong seismic events throughout history. Stone churches collapsed, homes crumbled into dust, entire neighborhoods were damaged. Yet the Leaning Tower remained standing. At first, many believed it was pure luck. Others claimed divine protection. But modern science revealed a far more fascinating explanation. The very weakness that caused the tower to lean also protected it. Beneath Pisa lies a unique combination of soft clay, sand, and groundwater. Normally, soft soil is considered dangerous for heavy structures. But during earthquakes, this soft ground behaves differently. Instead of violently transferring seismic energy upward, it absorbs and disperses vibrations. Engineers call this phenomenon soil structure interaction. When seismic waves travel through the earth, rigid buildings receive the full force of shaking. But the Leaning Tower responds more like a flexible object balancing on a cushion. As the ground moves, the tower gently sways rather than resisting the motion. This prevents destructive resonance, the deadly effect that causes many buildings to collapse. Ironically, if the tower had been built on solid rock, it might not have survived centuries of earthquakes at all. Its imperfection became its shield. This discovery changed how engineers understood historical architecture. The tower was no longer seen as a failed design. It became a real-world laboratory demonstrating how flexibility can sometimes outperform strength. And this lesson extends far beyond Pisa. Around the world today, modern cities face a similar invisible threat: ground subsidence. In cities like Jakarta, excessive groundwater pumping has caused entire districts to sink rapidly. Some areas descend more than 20 centimeters each year. Buildings tilt, roads crack, flooding becomes unavoidable. Even famous landmarks are not immune. In London, engineers carefully monitor subtle movements around the clock tower known as Big Ben. In New York City, massive skyscrapers slowly compress the soil beneath them under enormous weight. The same forces that shaped Pisa centuries ago are still active beneath our feet. Gravity never stops working. The difference is that today, millions of people live inside structures affected by these hidden changes. The Leaning Tower of Pisa reminds us of an important truth. Engineering is not always about fighting nature. Sometimes survival depends on understanding how to move with it. And as scientists continue studying the tower, it quietly teaches lessons that may help protect future cities from disaster. By the late 20th century, the Leaning Tower of Pisa was no longer just a historical curiosity. It had become a global emergency. For centuries, the tower had leaned slowly, almost invisibly. But by 1990, measurements revealed something terrifying. The tilt had reached its most dangerous angle in history, more than 5.5 degrees. The top of the tower had shifted over 5 meters from its original vertical line. Standing near it felt unsettling. Visitors described the sensation as if the massive structure could collapse at any moment. Engineers ran advanced computer simulations. The results shocked everyone. A strong storm, heavy rainfall, or even minor ground changes could trigger a catastrophic failure. The Italian government made a dramatic decision. The tower was immediately closed to the public. Tourists were evacuated. Security barriers surrounded the entire square. For the first time in centuries, silence replaced the sound of visitors climbing its spiral stairs. News channels across the world began broadcasting live reports. Some journalists predicted the tower would fall within weeks. Hotels nearby filled with people hoping to witness what they believed would be a historic collapse. Rumors spread rapidly. Some claimed the government planned to secretly dismantle the tower at night. Others believed hidden cracks had already appeared deep inside the structure. Fear grew stronger each day. Inside restricted zones, engineers worked under enormous pressure. Their first goal was simple: prevent immediate disaster. Massive steel cables were carefully wrapped around the lower levels of the tower. These acted like a safety belt, preventing sudden movement. Then came another desperate measure. Huge lead counterweights were transported during nighttime operations. Block by block, hundreds of tons of lead were placed on the higher northern side of the foundation. The idea was to shift the center of gravity backward, slowly, carefully, millimeter by millimeter. Sensors installed throughout the tower monitored every vibration. Engineers slept only a few hours each night, afraid that one wrong movement could end 8 centuries of history. Every adjustment required patience beyond imagination. Too fast, and the tower could crack. Too slow, and gravity would continue winning. For months, the world waited. Would humanity finally lose its battle against physics? Or could science achieve what generations before had failed to do? The answer depended on one final, incredibly risky idea. An idea so unconventional that many experts initially called it madness. The final solution to save the Leaning Tower of Pisa sounded almost unbelievable. Instead of trying to push the falling side upward, engineers decided to do the opposite. They would slowly lower the higher side. The plan was called controlled soil extraction. It required precision never before attempted on a monument of this scale. Special drilling machines were installed beneath the northern foundation. But these were not ordinary drills. They were long, narrow instruments designed to remove tiny amounts of soil at a time. Not tons, not kilograms, sometimes only a few handfuls each hour. The idea was simple in theory but terrifying in practice. As soil was carefully removed, gravity would gently pull the higher side downward, reducing the tilt naturally. Every movement was monitored by hundreds of sensors. Laser instruments measured shifts smaller than a human hair. Engineers watched screens day and night, ready to stop instantly if stress levels increased. The entire operation felt less like construction and more like delicate surgery on a living patient. Weeks passed, then months. Slowly, almost invisibly, something extraordinary began to happen. The tower started correcting itself. Millimeter by millimeter, the dangerous angle decreased. The structure stabilized. Against all expectations, the plan worked. By the early 2000s, the tilt had been reduced by nearly half a meter. For the first time in centuries, the tower was no longer moving toward collapse. In 2001, the barriers were finally removed. The Leaning Tower reopened to the world. Tourists returned, climbing the same spiral staircase that had once been feared unsafe. But now, hidden around the monument, advanced monitoring systems constantly tracked its condition. Satellites, sensors, and laser scanners continue watching every tiny motion. Today, experts believe the tower will remain stable for at least another 300 years. What began as an engineering mistake became one of humanity's greatest scientific victories. The Leaning Tower of Pisa is no longer a symbol of failure. It is proof that imperfection can become identity, that mistakes can lead to discovery, and that human curiosity, patience, and science can challenge even the unstoppable force of gravity. For more than 800 years, the tower has leaned, not because it was weak, but because it survived. And perhaps that is why millions still travel across the world to see it. Not to witness perfection, but to stand before a monument that refused to fall. Even today, the Leaning Tower of Pisa continues to teach us something important. History is not only built by perfect decisions. Sometimes, humanity learns the most from its mistakes. The tower reminds us that progress is rarely straight. It bends, struggles, and adapts, just like human civilization itself. Every stone carries centuries of fear, innovation, and determination. Generations of engineers faced a problem they did not create, yet refused to abandon. And because of that persistence, a structure once considered a disaster became one of the most recognized landmarks on Earth. Standing beneath the tower today, people are not just looking at architecture. They are looking at time itself. A reminder that even when something begins to fall, knowledge, patience, and science can help it stand again.